Hello class, it's Mr. Ng, and I am sorry I can't be there with you. I'm hoping that this video can help kind of make up for some lost instruction. I'm just really sick. Let's get started. Notice that I skipped numbers 1, 2, and 3 just because that depends on some prior skills. So let's skip to number 4 first, just so that we don't need to review balancing and all those name things. I do have one more problem in this set that will go over that, but I just want to do something real simple first. Okay, so number 4 is asking, assume that 5.6 liters of hydrogen gas at STP, that's awesome, STP, reacts with copper 2 oxide with this balanced equation. Awesome. Two things are given to us, a balanced equation, great, and STP. STP is awesome because we know that we can use 22.4 liters of gas at any 1 mole of gas, right? That's what happens when we see STP of gas. Great. And this thing is already kind of balanced for us, so less work for us. So let's start with part A. How many moles of H2 react? Let's start with our given. 5.60 liters of H2 gas. Can we go from liters to moles, right? Yes, we have this here conversion unit. So let's go from liters of H2 gas into moles of H2 gas. And we know that every 1 mole of gas is 22.4 liters of gas, right? Notice that I didn't write 22.4 on top because 1 and mole are married and 22.4 and liters are married, right? And we wanted liters on the bottom. Just simple dimensional analysis rules. If I do that math, I get 0.25 moles of H2. Great. Let's do part B. How many moles of copper are produced? Well, if we have 0.25 moles of hydrogen, I can use the balanced equation to go from hydrogen to copper by using the coefficients in front. I don't see any numbers here, so I'm just going to assume a 1 there. Right? So we can go from moles of H2 to moles of copper. And it's a 1-to-1 ratio, meaning that number does not change. It's also 0.25 moles of copper. Great. And then finally part C, it wants the grams of copper. So we already know that we have 0.25 moles of copper, 0.25 moles of copper. Can we go from moles of copper to grams of copper? Of course we can. Moles of copper to grams of copper. Really old school stuff. All we got to do is use the molar mass. So we know that every 1 mole of copper is 63.55 grams of copper. So if we do that math, it's just 0.25 times 63.55, and I get 15.9 grams of copper. Good. Notice that almost all of this stuff is stuff that we already know. Just old school dimensional analysis, use the molar mass. The one thing that's new is that we're using 22.4 liters of gas per mole. All right. Let's do one more. This one's asking for a little bit more. Again, there's a lot of older skills here that we need to remember. Notice that there's no balanced equation. Instead, it just gives us iron 3 hydroxide decomposes to make iron 3 oxide and water. So first thing we got to do is we got to name these things. Iron 3 is Fe3 plus, hydroxide is OH minus. For them to make an ionic compound that they balance out, we do the old switcheroo. So that means it's FeOH3, right? Old school stuff. This is iron 3 hydroxide. Iron 3 is right here, Fe3 plus. Oxide is O2 minus. Again, do the old switcheroo. That means iron 3 oxide is Fe2O3, and water is, of course, H2O. So we know that FeOH3 becomes Fe2O3 and H2O. And now we got to balance it real quick. So we got Fe's, we got O's, we got H's. We got irons, we got O's, we got H's. Let's do an initial count. There's 1 iron, there's 3 and 3. There's 2 irons, and then there's 4, right? 3 plus 1 and 2. So I think the first thing I'll do is just put a 2 here. Boom. This becomes 2, 6, 6. This becomes a 6. What can I make into a 6? You know, this hydrogen there's 2 of them here, and I could probably get to 6 hydrogens by putting a 3 here. So now I have 3 hydrogens, so that becomes a 6. The oxygen becomes all messed up, so this is 3 oxygens plus another 3 is 6. Hey, it's balanced. 2, 6, 6, 2, 6, 6. So it's a 2 and a 3 here, and then 1 here. All right, fine. So now let's start working. How many grams of iron 3 hydroxide were used when our given is 75 liters of water vapor? So A, we have 0.75 liters of H2O. First step of every Stoic problem is to get to moles. And we remember 22.4 liters per mole, right? So let's get out of liters and into moles, right, of H2O, H2O. 1 mole is 22.4. Good. Get out of liters. We're now in moles of water, and it wants hydrogen, iron 3 hydroxide. So we could go out of moles of water and into iron 3 hydroxide, FeOH3. To do that, we're going to use the coefficients. For 3 moles of water, there are 2 iron 3 hydroxides. Good, right? And then we need to find the actual grams. It wants grams of iron 3 hydroxide. So for every 1 mole of iron 3 hydroxide, it's certain grams, and we don't really know that except we have to do some math, right? So there's 1 iron, there's 3 oxygens, and there's 3 hydrogens. So hydrogens times 3 is 3. 16 times 3 is 48, so there's 48 here, and then there's one of these guys, 55.845, right? So I just got to add all these up, right? If you don't see what I'm doing, I'm just finding the molar mass of iron 3 hydroxide. So it's going to be 55.845 plus 48 plus 3. So I got 106.85 grams of FeOH3. Now let's make sure we know what we did here. Here we use this because it's at STP. Here we use the balanced equation. And here we use the molar mass. A lot of skills coming together to do gas stoic, right? So let's get through this. So it's 0.75 divided by 22.4 times 2 divided by 3 times 106.85, and I got 2.39 grams. 2.39 grams of FeOH3. Good. Let's try that again, but this time we're going to do iron 3 oxide instead. So let's find the molar mass of iron 3 oxide. Iron 3 oxide is Fe2O3, so there are 2 of these. 55.845 times 2, so there is 111.69 here, and there are 3 oxygens, so 16 times 3 is 48 again. So 48 plus 111.69, that's 159.69. So for this thing, it's 159.69 grams per mole. Okay, so let's do B. How many grams of iron 3 oxide were produced? We could go through all these steps again. So let's just go through 0.75 liters of water, right? we're going to convert that to moles. 1 mole of water is 20 divided by 22.4 liters of water. Fine. This time we're not going to convert to iron oxide. We're going to go from moles of water. And this time we're going to go to this guy here, right? The iron oxide. So for every 3 moles of water, there's 1 mole of Fe2O3. Good. So now these have canceled. Now we're in moles of iron oxide. So to go from 1 mole of iron oxide, we know the grams of iron oxide. All right, we just did that math. It was right here. 159. 159.69. So now we do some math. 0.75 divided by 22.4 divided by 3 times 159.69. And this time I have 1.78 grams of Fe2O3. Okay, I know that this bit is a lot of math, and I promise you our next unit will be much less math, and in many ways this is a culmination of all of our skills put together. So gas stoic is pretty darn important. So all I can advise is that we practice quite a bit. So remember to practice, keep practicing, go nice and slow. We'll do this together, and I hope you have a good day.